Hello everyone. In this video I am going to demonstrate power line communication for data signal using ASK modulation and demodulation technique. This is the final part of this video where the data is finally processed by the Arduino Uno and it is displayed on the computer console. So as you can see here, this is the transmitter Arduino circuit. This is the transmitter Arduino board. So this transmitter Arduino board is going to send alphabet R continuously, sequentially, and the same alphabet has to be received by this Arduino Uno board. So from here the data will be transmitted and the data will be received on this Arduino Uno board. But the data will be modulated using a 48 kHz signal in between here, and it will be transmitted all along the power line between the two transformers. Finally the data will be demodulated and the data will be optically isolated and it will be sent to this Arduino Uno. So as you can see here, I am going to describe the circuit, how it is built. The transmit pin of the first Arduino Uno, transmitter Arduino Uno, is transmitting the data and it is received here. You can see the flashing LED. So this flashing LED is catching the data and it is optically isolated here. So from here I am sending isolated data to the 555 timer circuit. You can see, so here the ASK modulation is taking place by the 555 timer circuit, and from the pin number 3 I am getting the carrier signal, modulated signal. I am getting the modulated signal. Thus the 555 timer IC is generating the carrier, but when it is mixed with the data, I am getting the final modulated signal at pin number 3. The pin number 3 modulated signal is fed to this power MOSFET using this current limiting resistor, and this power MOSFET is driving this primary transformer. The transmitter transformer. This transformer is in the transmitter end. So this is the transmitter transformer. This is a high frequency transformer wound on a ferrite core. As you can see, it has 10 turns in the primary winding and 10 turns in the secondary winding. So the transformer is basically, one end is tapped with the 12 volt DC bus and the another end is connected to the drain of this MOSFET. The secondary of this transformer is connected to another transformer as if it is connected on a long power line. We can analyze it as if it is connected on a long power line, long distance power line. So this is the transmitter end transformer and this is the receiver end transformer. You can see the receiver end transformer has 3 windings. One winding is connected to the primary end transformer and the second winding is connected for the DC supply. You can see here AC to DC is done by one winding and another winding is used for the demodulation purpose. So the winding used for the demodulation purpose is fed to the demodulator and the data is demodulated here and it is fed to another optical isolator. You can see beneath there is another optical isolator. So the data is fed to this optical isolator. The secondary part of this optical isolator has an inverter as well, and finally the data is sent to this Arduino Uno. You can see the LEDs are blinking. I will show you the data capture. So this is how the circuit is wired. So let us look into the circuit diagram first. So this is the layout of the circuit diagram. You can see, so the transmitted data is arriving here. It is optically isolated by this optical isolator MCT2E, and from here you can see there is a 12 volt DC pull-up line and this resistance is 10K and this optocoupler is MCT2E. So as you can see here, this is MCT2E optocoupler optically isolating, and here you can see the data will come here like this. So this data will be in phase with this data. There is no phase change. You can see, that's why I pulled up the data here. So from here the data will come and it will be fed to pin number 4 of the 555 timer IC. So here this is an oscillator oscillating at a frequency of 48 kHz. The output will be a modulated signal fed to this MOSFET IRF840. So this is the MOSFET IRF840. So the drain of this MOSFET is connected to this transformer. Another end of the transformer is connected to the 12 volt DC bus. The secondary of this transformer is the real power line carrying power and data together. So this line is coming all along, and here you can see there is a receiver transformer. The receiver transformer has two windings. One winding is the power winding. This is the power winding for driving the power device, and this is another winding. This winding is used to demodulate and receive the data. So basically this is a demodulator. The output of this demodulator is fed to this another optical isolator. This is the second optical isolator, and finally here with after an inverter, the data is fed to Arduino Uno. This 5 volts DC is the Arduino receiver voltage, and this ground is the Arduino ground voltage. So like this you can see the receiver is isolated and the transmitter is also isolated from the modulation units. So as you can see here, the DC out section of the circuit has a Schottky rectifier and a filter capacitor. So let us see the DC voltage first. You can see the DC voltage is 9 volts, and you can see there is no AC component. This is a pure DC of 9 volts. You can see this is the waveform. So this is the modulated signal with the carrier, and this is the final data at the Arduino Uno. And you can see here the receiver and data capture is going on. I am receiving alphabet R continuously. There is no error in the signal. So this is how the circuit works. Thanks a lot. Thanks for watching.